Hello, my name is Parth Patel and my group members are Siddhant and Saransh Thakur. So we are presenting the bike sharing in Washington. So we are gonna predict the demand of the bike sharing in the Washington area. So the goal is in what time and in what season of the year the there is all highest demands of bikes. So like we have many companies like DV, 6L, City Bikes, Strike Bikes. So on what time there is a maximum use of bikes are demanding and people use the e-bikes on what time and in what time of the year or what time on the day. So our objective is the strategic bike placement of dynamic demand fulfillment by balancing the customer satisfaction and probability. So by from the data set we can by generating the model and giving the output that on in this time or the in this specific location there is the highest demand of the bike during this time, so we can provide this to the our customers like big companies, and they can improve their business. That's our vision. So we have a data with 21 variables and 17,379 different records, and there is only 1 year. There is only 1 year of the timeline of the data sets. So there are key variables are date, season, year, month, hour, weather, temperature, humidity, wind speed, and user counts. The temperature variables that are also included in the Celsius, and we are normalizing the temperatures. And environment variables are the humidity and the wind speed, and there is a different weather conditions like a clear, few cloud, partially cloud, mist, cloudy mist, the broken clouds, mist plus few clouds, mist, high snow, thunderstorms, scatter clouds, light rain, like etc. So we're gonna standard the exploratory data analysis and the building a different model from those EDA, uh, and then conclusion and feature scopes. So talking about the uh, data analysis, actually data analysis, we have average demand for different months. So from we can see that the June and the September are the months when there is a maximum use of people do the maximum use of the bike sharing system. And the June and July and the August are the after the following months after the September and the June. We can see that the January and the February and March there are least people use the least amount of the e-bikes. Uh, Talking about the seasons, we can see that fall and summer has the highest demand during the year. And talking about the wind speed, the the data said we are working with the higher. There is not much wind speed. We can see there is only 0 to 0.4 wind speed is available. So we can see that our data set is pretty good. Wind is not affecting that much. Also, the temperature data seems to be spread out in the next graph. We see the temperature data is spread out. We ensure that we are meeting the demand for the temperature value by using the distributed temperature data. From observing the third graph, in what time of the bike demand is high, so we can see at the 5 p.m. in Washington City, at the 5 p.m. people are most using the bike sharing system. There's the most demand of the bike. In the morning time, 1 to 7, there is a least use of the bikes. And then after 8 a.m. to the throughout the day, demand is increasing. So then we build the different models, uh, different machine learning models. First, we apply the linear regression model. After applying the model, we got the mean absolute error 0. It means we are predicting the value is exactly equal to the true or observed value. This is ideal, and this is the perfect model and the perfect prediction on from our given data sets. But it's still there is a complex relationship between the variables, or the data is noisy. So we try the different algorithm and we apply the k nearest neighbor algorithm. And since there is a difference in prediction made by the model and the test data, smaller k value indicates the better performance of MSE and the MER. But when the neighbors are increasing, the error mean absolute error is also increasing. And it seems we need a further investigations, and so we applied the PLS regression model. So based on the findings, we can observe that the base number of the components is 5. The particular value yields the absolute error and the relatively low mean square as well. So, talking about the PLS regression, and after considering the interpretability and the model compounded efficiency overfitting, it seems PLS is performing well compared to the linear regression and the KNN algorithm. Then we applied the decision tree. So, and determine that the ideal value for the depth in terms of minimizing both the mean square error and the mean absolute is at 20. It seems the model is performing well. We are looking at the predictions. It also seems it's good and it's close to 0. Means it's predicting what we want to predict. Overall, the model is performing well, but it's not satisfying as it should be. So we applied the gradient boost regression model. So after we applied that on our bike prediction model, and we all know that this algorithm is known for its ability to capture the complex relationship among the datasets from the output table. It seems that it's performing the best compared to the Canon PLS because it's offered the error, least square error compared to the all other models like PLS, decision, and the k-neighbors. So after all, we captured the bike prediction using the ML algorithm to predict the price, and we applied the different extra data analysis to try to understand the what data is saying and compare the relationship between the different variables, and then try to predict the building the model by applying the different ML algorithms like PLS, gradient, and the decision tree. So the project provides the valuable data to the stakeholder with potential for the future improvements in feature engineering the model selection. But there's a feature we need in order to enhance the accuracy of the bike demand prediction model. It would be beneficial to incorporate the data, such as we have to also consider the another data set like a connectivity of streets, public sentiments toward the cycling in particular area or in particular season, or there is any other trending mode of the transportation or not. This would be enable the models to make forecast. Moreover, the utilizing the machine learning model in the time help identify the regions and significant demand for bikes. So thank you for considering our analysis of the bike sharing. We hope you found insight valuable. Thank you.